Okay, this is a review of LO1. It's all about statistics. As usual, I advise you to do the review before you watch this video. Okay, the first question is talking about the population of a survey versus the sample of a survey. So it's a vocab question. Okay, so remember the population in a survey is who or what do you want to know about? And the sample is who specifically did you ask? Remember, you can't always ask the whole population. Sometimes that's thousands or millions of people. So you ask just a small sample, 100 or 200 or something like that. Okay, so let's read the question. It says there's 2,000 clothing stores in the UAE. That sounds like the population that I want to learn about. And then it goes on to say, okay, well, we asked 30 clothing stores in Dubai and 20 clothing stores in the other Emirates. That's who we asked. So when it talks about the population, it's all the clothing stores in the UAE, which in fact they said there were 2,000 of them. Obviously, we can't ask them all, but that's the population that we want to learn about. Now, it's not all stores, it's just the clothing stores. Okay, who did we ask? We asked 30 stores in Dubai and 20 stores in the other Emirates. They're both clothing stores, so they're not all in Dubai. It's not just the 20 stores in the other Emirates. It's 50 clothing stores in the UAE. Okay. So in summary, we wanted to know about all the clothing stores in the UAE, that's the population. So we asked 30 clothing stores in Dubai plus 20 clothing stores in other Emirates, which is 50 clothing stores in the UAE. That's who we asked. That's the sample. Okay, the next question is asking about qualitative data. So actually, let me first go into the vocab of the difference between quantitative and qualitative data. Okay, quantitative data has to do with numbers. The answer will be a number. And qualitative data is words. Now, the question is asking us about qualitative data. So we want the answers to be words. Well, look at the first one. Age is a number, so it is not qualitative. Educational qualification, that means things like bachelor's, master's, which is a word. This is a word, so it is qualitative. Years of experience, again, I have 5 years experience, I have 10 years experience. Those are numbers. So actually, the qualitative data is only choice B. Okay, another vocab question. It's asking about discrete variables. So before we go into this is when you have quantitative data, when you have number data, it's either discrete or continuous. So what's the difference? Discrete data is things you count. Okay, and so they are going to be whole numbers. Continuous data, on the other hand, these are things you measure. So these can have decimals. Okay? So let's look at each option. The number of cars on the road, that's something I count. You have 1, 2, 3, 4. You're not going to have half a car. So this would be an example of discrete data. Number of passengers, again, that's something I count. I'm not going to have half of a passenger. Okay? Speed. Now that's something you measure. And you can totally have a decimal. You can totally be going 100.5 kilometers per hour. So that would be continuous. So the answer to this question is both choice A and B are discrete. Okay, this next question is an example of a grouped frequency distribution. Okay, here on the left where it talks about the class limits, that's our data. And on the right is the frequency. So for example, 6 people or 6 items fell into this data point, somewhere between 50 and 54. 4 people or 4 items fell into this class limit here, 55 to 59, and so on. One thing they didn't ask, but I'm just going to point out, the class with the biggest frequency, this one is going to be called the mode. Okay, it's the most popular range of data points was between 60 and 64. Okay, when it talks about, for example, for part A, the class width. So look at the class widths. They're going from 50 to 54, 55 to 59. Now, normally the common mistake is people subtract those two and they say the width is 4. But that's a problem. So I'm going to say it's not 4. Okay, why? Because in this class, you've got the number 50, 51, 52, 53, and 54. So if you count 1, 2, 3, 4, 5, there are 5 data points in that class. And so you'd say the width in this case is 5. So you must include both endpoints. And so in that case, you have a width of 5. All right, let's look at the midpoint. Midpoint should be an easy enough question. So the midpoint, what you do is you take, for example, 70 plus 74, and you take the average of those endpoints, you divide by 2, and you end up getting 72 is the midpoint. Okay. And then the boundary. What's the idea of boundary? Okay, boundary is saying, listen, I don't know what I'm measuring here, but what if it is continuous data? What if it's, for example, speed limits? So, or weight. It looks like it could be weight. What if I weighed 54.5? Would I go in the first column or the second column? I'm not sure. So when you have just whole numbers and we want a boundary, basically what you do, so for example, the number 7, the class 70 to 74. If I weighed 69.9, I would still be in that class. So what you have to do is you basically have to subtract 0.5 on the left endpoint and add 0.5 on the right endpoint. And then you get the boundaries. Basically, they will include boundaries, every single endpoint, every single decimal continuous value. So you'll know, like if I was anywhere bigger than 69.5, bigger than or equal to 69.5, or less than 74.5, then I would fit in that class. Okay, so when they ask for a boundary, you just subtract 0.5 from the left and you add 0.5 from the right. Okay, here is a question where they're wanting us to analyze, to answer questions about a bar graph. So before I look at the questions, let me just look down and see what it's saying. Types of pets. I don't know what oats means. I'm going to have to say that must mean goats, but I don't know. Looks like 20% of the people preferred goats, 25% dogs, 10% hamsters, 5% is snakes, another 25% is bird, and 15% is fish. Does this add up to 100%? 45, 50, 60, 85. Yep, 100%. Okay, so when they're asking in part A, what percent chose dog or hamster? So let's do them separately. Dog was 25%. Okay, hamster was 10%. Now, usually I would say, remember, from LO3 we don't add percentages, but in this case it's actually fine. That's what or means. One or the other means you can add them both up. So the answer in this case, 35% chose one or the other. How many pets are chosen by less than 15%? So here's the 15% mark. Now, it didn't say less than or equal, just less. So in this case, it's just the hamster and the snake. So that's 2 pets. 2 pets, hamster and snake. Both of those had fewer than 15% of the population. What percent of students prefer dogs over fish? So here's dogs. Here's fish. So dogs was 25%, and fish was 15%. So when we're comparing one to the other, we just subtract. So 25 minus 15, there's 10% more that prefer dogs. If you were thinking of it as people out of 100, 25 people said dogs, 15 said fish, that's 10 more. So 10 out of 100, 10%. Okay, hopefully interpreting the bar graph is not too hard. Okay, this next question is all about measures of center, which just as a reminder is mean, median, and mode. And more of a reminder, mean we call the average, where you add all and you divide by the number that you added. So it's the summation of the x divided by how many. The median, we do call that the average, but it's called the positional average. So better, I'll call it the middle position. And that's where you line everything up from smallest to biggest, and you pick the middle. And then lastly, the mode is the most repeated, the most common. And by the way, this is the one that we use when we have qualitative data, because you can't add up or line up from smallest to biggest words. You can only do that with numbers, quantitative data. So let's answer these questions. Mean always exists in quantitative data. That's true. Whenever you have numbers, you can always add them up and divide by how many. Mean is affected by extreme values. Also true, if you have a very big or a very small number, when you add it up and divide by how many, it will pull the mean, it will pull the average either very big or very small. Mean is always positive. Well, here's an example of something false. If all your data is negative, like for example, the temperature in Alaska, if all of the data that you collect is negative, when you add it up and divide, you're still going to get a negative answer. Mean is easily found for qualitative data. Now, of course, this is false. Remember, qualitative data means words. You can't add up words. Median is a calculated average. Again, that's false. Calculated means adding them up. Mean is actually what we call the positional average. It's the middle position. Okay? Median is always unique. It means there's only one median for a set of data, and that's true. There is only one median. The median is affected by the extreme values. That's false. So when we have extreme values, that's a value that's very big or very small, the mean is affected. And that's why we don't like to use it. Instead, we use median, because when you're just lining up things in the middle and you're taking the middle value, doesn't matter if one on the end is very big or very small, the middle will still be the middle. Okay, so that's the advantage of using the median when there's extreme values. So it's not really affected by the extreme values. The median can be negative. That's true. Again, if you have negative data like temperatures in Alaska, the middle one will also be negative. The median is always smaller than the mean. That's false. There's no way to know. Just depends on the data, which is bigger, mean or median. Mode can be determined from quantitative data. That actually is true. Even if we have numbers, you can find a mode. You can find the one that's the most repeated. But sometimes, going down to choice K, sometimes the mode does not exist. It's not true that it always exists. If nothing is repeated, there is no mode. Okay. Let's go to the next one. There is one and only one mode in a set of data. Also false. It's possible to not have a mode. It's possible to have more than one mode if there is a tie for the most repeated data. Okay, next question is talking about standard deviation and variance. These are called measures of dispersion, which is how far apart the data is. And remember, there's 3 different ways to measure the dispersion of a set of data. There's the range, the standard deviation, and the variance. The range just measures the highest data point minus the lowest data point. The standard deviation is just the average distance from the mean. And the variance is just that standard deviation squared. So let's look at the statements and we'll go through them one by one. A smaller standard deviation indicates more consistent data. That is true. So a smaller standard deviation means the distance away from the mean is small. It means the data is close together, which is called consistent. Okay, the next sentence. The value of the range is smaller when there are extreme values in the data set. That's actually not true. Extreme values means there's very big numbers or very small numbers. So when you do the range, the high minus the low, it would be quite big if you had a very big number or a very small number. Next sentence. The standard deviation takes all the values into consideration. That's true. So the standard deviation looks at every data point, sees how far is that data point away from the mean, and then takes the average of those distances. So the standard deviation, it does take all the data values, and that's why we use the standard deviation and we like it a lot. Okay, next sentence. If all the data values are equal to the mean, then the standard deviation is 0. That's actually true, because if all the data points are sitting on the mean, then the distance away from the mean is 0 for all the data points. So if you average all those distances of 0, you'll still get 0. Next sentence. The standard deviation is a measure of central tendency. No, it's a measure of dispersion, how spread out the data is. Central tendency is mean, median, mode. Okay, next sentence. The variance is the square root of the standard deviation. No, if you look, the variance is the standard deviation squared, not the square root. The standard deviation is the square of the variance. Let's write this. No, in fact, the standard deviation is the square root of the variance. Basically, they confused these 2 sentences. Okay, next sentence. The numerical value of the standard deviation is always positive. That is actually true because it's just an average of the distances away from the mean. Those distances are always positive, so the average of the distances is positive. So yes, standard deviation and variance will always be positive. If the variance is large, the data is less varied. This is not true. Large variance means the data is spread out a lot. So it means it's more varied, it's less consistent. So just as a review, a large variance means the data is spread out, which means it's more varied. Less consistent, more varied. Okay, so this question has a lot that it's asking, but it's all about raw data. Okay, so when you have raw data instead of a table, it's sufficient when it asks for the mean just to add everything and divide by how many you added. 1, 2, 3, 4, 5, 6, 7. So if we add all for the mean and divide by 7, so the mean is the sum of all the data divided by the number of data points. So in this case, we get a mean of 43. Okay, the median, you take them all the data points, you line them up from smallest to biggest. So let's do that. We've got 13 and then 25 and then 38, 39, 44, 71, and 71. That's 1, 2, 3, 4, 5, 6, 7. So the middle data point is this one. That is the median. If there were 2 in the middle, you just add them up and divide by 2. You find the middle of the middle. And in this case, there's only 1, so it's an easier question. Mode is the most repeated. Okay, so if nothing was repeated, you would say no mode. If there is a tie, you can give more than 1 mode. But in this case, the only thing repeated is 71. So that's the mode. Okay? Part D, the range. The range is the big data point minus the small data point. biggest minus the smallest. So in this case, that is 71 minus 13. So the range is 58. Now, when it's talking about variance standard deviation, we need to use our calculator. And one thing is the calculator actually gives us the standard deviation, and then we use that to get the variance. So let's actually start with part F. And you need to use your calculator. You need to do mode 3-1, and then you enter your data. And since it's raw data, you'll just put all the numbers 13, 44, 71, all that on the left, and it will just populate the frequency of 11111 on the right. Then you press AC. And then to calculate the population standard deviation, that's going to be shift 1, 4, and population standard deviation is this Greek letter, sigma. So shift 1, 4, 3, and you'll get sigma, which is the population standard deviation. In this case is 20.12, if we're going to round to 2 decimal places. Okay, and then you can go backward and do part E, which is just the variance is equal to the standard deviation squared. So I type in my calculator answer squared, and we get 404.86. Now we can do the same exact thing with sample standard deviation, and it will specify one way or the other in any question. So we're going to actually start with H. We'll do the sample standard deviation. Our data is already in there. You just do shift 1, 4. Now this time 4, the letter S. Okay, so we'll do shift 1, 4, 4. You get the sample standard deviation is close. It's a similar number, but a little bit different, 21.73. And then again, if you want to find the variance, which is part G, we'll do, the variance just equals S squared, which is just your answer squared. And you end up getting 472.33. Now it'll say in the question whether it wants population or sample. Okay, this is a similar question, but now instead of raw data, we're given a frequency table. So the first thing we do is we press mode 3-1, we enter the data, then we press AC. But even before that, as I started typing, I noticed a problem with the data. It's not really a problem, it's just not that nice. The data is out of order. So better to put it in order. This will help us, especially for the median question later. Okay, so now I rearranged the frequency table so it's going in order from smallest to biggest. This will help us later. And I did mode 3-1, I entered the data, press AC. Now if you do shift 1, 4, and 2, you'll get the median. The mean. Okay, so the calculator says the mean is 59.6. Now the median's a little bit trickier. So what you need to do for the median is make another column called the cumulative frequency. So we start with 2, we add 1, we get 3, add 6, get 9, add 7, we get 16, add 5, we get 21, add 4, we get 25. So you look at this number, divide it in half, since median is the middle number. So half of that is 12.5. So I want to look, where is the 12th or the 13th number? Well, these are the first 2, first 3, first 9. So the 12th and 13th number are here. And so therefore we can say the median is that data point 60. Okay, the mode is the most repeated, which means it has the biggest frequency. So if you look, the biggest frequency is also at 60. The range is the high minus the low. The highest data point is 80. The lowest is 30, high minus low. So the range in this case is 50. Now it's asking for the standard deviation, and I look up at the question and it says sample standard deviation. So I type shift 144 in my calculator and I get 14.28 if I round to 2 decimal places. And then the last one, it's asking for the variance. And the variance is just equal to the standard deviation squared, so I'll just type in my calculator answered squared, and I get that the variance is 204 exactly. Now this next question is a grouped frequency distribution, which means the data on the left has classes or categories. So what we have to do before we can use our calculator is we have to actually find the midpoint of each class before we can enter it in our calculator. So here are the midpoints. How did I find those? You just take the endpoints of each class, add them up, and divide by 2. So in that case, I got 24. 27 plus 31 divided by 2 is 29, and so on. So let's look at the questions. The first one, how many employees are 36 years old or younger? So that's how many are in those first 3 categories. So that's 5 plus 4 plus 6, and we get that 15 employees are 36 years old or younger. Part B, where it's asking for the mean, let's enter everything in our calculator, the midpoint and the frequency. So we do mode 3-1, and then to get the mean, we do shift 1, 4, 2, and we will get that the mean is 32.25. Okay, now part C is asking for the standard deviation, and when it says all employees, that's talking about the whole population, not just a sample. So we'll say the population standard deviation, and in this case you do shift 143, and we will get 6.379. That's rounded to 3 decimal places. And then the last question, part D, where it's asking about the variance, you just do the standard deviation squared, which is just, I pressed answer squared, and we get to 3 decimal places, 40.688. Okay, so same stuff. Let's move to another question. Okay, and this is a word problem to do with mean, which my advice always when you have a mean word problem is you calculate the sum of all the data. And that you can calculate by knowing the mean and the number of people or the number of items. So let's see what the question says. It says the average age or the mean is 30 years and there's 10 players. So I write that information down, and now I'll find the sum. So in this case, it's 300. So what that means is I know all the players have different ages, but we know that since the average is 30 and there's 10 of them, that all their ages add up to 300. But now look what happened. Someone who's 22 leaves, and someone who's 32 joins. So let's account for that in the sum. So the sum of their ages now are going to be a little bit more because an older guy replaced a younger guy. And now we want to know the new average. So remember, for average, you just add up all the data points and you divide by the number. So we know the new sum is 310. We still only have 10 people on the team, so the new average is 31 years old. Okay, the last question is talking about the vocab words consistent versus variable. Remember, consistent means the data is close together, which means the standard deviation and the variance are small. Variable means the data is spread apart, which means the standard deviation and the variance will be bigger. Okay, so now they're talking about 3 different sets. So let's organize the information. There's 3 different sets. Now notice they gave us the standard deviation of A and B, but then they gave us the variance of C. And you always have to compare same with same. So let's find the variance of A is the standard deviation squared. The variance of B is the standard deviation squared, 25. And the standard deviation of C, which wasn't given, is going to be the square root of the variance, which in this case is 3. Now, when we're talking about most consistent, we're saying which one has the smallest standard deviation or variance. So in this case, it's data set C. The data is going to be closest together. And then the one that's most variable is going to be set B because it has the biggest standard deviation or the biggest variance. That means the data in set B is the most spread apart.